Today I'm going to make a short video about how I made this knife sharpener. This is a pretty basic machine and I built it in an afternoon. You adjust the tracking of the belt with this fairly simple mechanism right here. This is nothing more than a threaded eye hook that I believe came out of a Christmas tree stand. And it is there's a wide hole, a large hole drilled into this stationary block, so this eye hook has some wiggle room, and then it's threaded into this block over here so that this block moves against this one as you thread it up and down the shaft of the eye hook there, and that in turn adjusts the tracking over here. Perfect. The motor came out of a treadmill that I had picked up on the side of the road. The treadmill actually didn't work. The control panel was busted, so I wasn't able to use the power source for the treadmill itself. So I improvised and used a laptop battery charger. Now this doesn't run the motor at full speed, but I actually think that that's a benefit for this machine, because for sharpening I tend to prefer a slower belt speed. I find it's a little bit more forgiving when you're honing an edge. This is a 19 volts by approximately 5 amp DC output. And this motor is rated for, I forget what it was, but I want to say it was 90 or 90 plus volts DC. Now, these motors are actually quite powerful. This motor is not very powerful, run off of this battery charger, but I find that it's perfectly sufficient for sharpening knives. The mounting bracket here that hooks to the pivot block actually came out of the treadmill, so that was pretty convenient. And the system is tensioned via this spring on the back. The drive wheel for this machine actually came out of a vehicle. It's a serpentine belt tensioner pulley. The ease of using this pulley on this machine was absolutely key for its function. In fact, this was probably my biggest hurdle in building the machine. Now, when you start with just a treadmill motor, it's going to look like this. In fact, these motors are very similar. So I'm going to show you how to remove the treadmill drive pulley, and I'm going to show you how I went about affixing this pulley to the motor shaft. Now, to remove this drive wheel off the motor, you actually have to unthread it from the shaft. This is not pressed on, it's actually threaded onto the shaft. You'll notice that a small portion of the shaft sticks out of the back here, and that's what we're going to utilize to lock the shaft in place so that we can unthread the drive wheel here. Now that we have the motor shaft secured in the vise, we can go ahead and twist off the drive wheel for the treadmill. Now, these are on pretty tight, and this particular one is reverse threaded. There we go. I'm going to give you a basic idea of how I have attached this drive wheel to this treadmill motor by showing you how to do it on this unmodified treadmill motor. I would do it on this one, but I've put this dust protective cover on the back of it, and I don't want to rip off all of this tape, so I can clamp this motor shaft and take this nut off. The shaft diameter on these motors is 11/16 of an inch, and that happens to be the exact inner diameter of the bearings that are used in these serpentine belt pulleys. Now, this is not a pulley that you would use for a project like this. As you can see, this one had a smooth surface. That's because it's made for the back side of a serpentine belt. That's why it doesn't have the grooves inside of it. So you'll want to find a pulley like this, but this one has a bearing design that is the exact same as the bearing design of this pulley. So I'm going to use this one to demonstrate how I have fixed it to the motor. The first thing to notice on these motors is the shaft has 3 stages to it. It has a thread, and then the main shaft, and then it's got this sleeve here. Now this sleeve actually is a depressed fit. So the shaft does not spin inside of that sleeve. The shaft is affixed to that sleeve, and I'll show you with this mark here. You see that? Because of that design, we can use that sleeve and this nut to essentially crimp this pulley in between. These have a bearing in them, and a bearing doesn't make a whole lot of sense on a drive wheel because you need the pulley to be fixed to the motor shaft. And the way that I did that on this machine was that I found a spacer at my local hardware store that I could slip onto that motor shaft. Now in this case, the spacer should be cut about in half. But just to give you a general idea of how this one is set up, a spacer goes onto the motor shaft and rests against this sleeve. And remember, the motor shaft is fixed to that sleeve. So now with this on, we can place our pulley on the bearing. And then with a large washer, we can then thread on a nut and literally crimp this bearing via friction to the motor shaft. And that's exactly how this one is set up. Now, what I used for a nut was actually the drive wheel that came off of the weighted drive wheel of the treadmill. You can see here that I simply sliced this off with an angle grinder, and I shaved it flat so that I could get a wrench on it and give it some torque. Behind that is a washer that makes contact with the rim of this pulley, and I cinched that all down in order to get a static fit to the motor shaft of that motor. As for the rest of the machine, I have 2 forward supports, one for the forward pulley, and then a platen mount. I specifically made this to be height adjustable, and my original intention was to make different sorts of platens that I could mount to this, but I ended up favoring just a simple spacer here, and I utilized this area right here to put a nice convex edge on blades. This is just a basic electrical box bought at my local hardware store, and this is a basic rocker switch, and it interrupts the power lead coming from the power supply here. The first thing that you probably noticed about this machine is that it is built out of high-density polyethylene. And the reason I did that is because I happen to have a lot of this material, and I picked up a lot of it on Craigslist for free. So this was simply the material that I had to make the machine out of. You could easily make it out of wood. In fact, I think that it would look a little nicer if it was made out of wood. This stuff gets dirty very easily. I actually cleaned this machine up just to make this video. It was already caked in metal dust. The other thing that you might be wondering is if there's anything about the machine that I don't really like, and there are. As with anything that you build, when you're done with it, if you're as critical of your own work as I am, there's always going to be something that you're not entirely happy about. And for me, it would probably be how I went about sealing the motor. I was in a hurry to get that done, and I wish I would have come up with a more elegant solution than simply taping it up. But it's worked so far, so I'm living with it. I'd also like to go with something other than a skate wheel. These wheels are actually pretty fragile, and this one is even cracking. I don't know if you can see that. Yeah. So this one is already cracking, and it's slowly deteriorating, but that's okay because I have extras. I would like something different, more heavy duty in the front there. Other than that, I wish that I would have spent a little bit more time rounding off some of these edges and making things look a little bit nicer. Other than that, I'm pretty happy with it. It works pretty well, which I will show you in a future video if you're interested in seeing it. And that is my knife sharpener in a nutshell. Thanks for watching.